Yes, welcome back for another exciting installment of Double Angle Formula. Right, I was getting too excited there. And it shouldn't be me that's getting excited, it should be you. So we dealt with sine 2x, so now we're going to deal with this character cos 2x, and it can cause a problem, okay? Because you did see earlier that for cos 2x, there was 3 replacements. So I've just put up 3 equations here. We know we're going to get rid of cos 2x in each of them. So don't concern yourself with that, that, or that. Don't concern yourself with that. Concern yourself with the other parts, the other trig parts. Do you notice each of them have single x and cosine? Right, so that's good. That gives you a clue. So the replacement for cos 2x should only involve cosine. Okay, and the only one that involves cosine from your formula sheet that you should have memorized is that one there. 2 cos squared x minus 1. That's the one that we're going to replace, okay, for the cos 2x's. Right. Okay, what about this one here? Well, we know cos 2x, cos 2x, cos 2x. Don't care about that. They're going to get replaced. It's the other trig parts that we're interested in. They've all got sin x. Okay, so the replacement here, we want only something that involves sin x. So that's the one, 1 minus 2 sine squared x. That's how we say it. That's what we're going to use here. The majority of the time, the third choice, cos squared x minus sine squared x, doesn't get used. But I'll probably put up an example of that just to show you where it can get used. In fact, I might put up a couple of examples. In fact, I might put up an entire lesson just to annoy you. Right, okay, here we go. So, let's go and solve for this. So, it's between 0 and 360, not inclusive of 360. Right, but you know it's cos 2x you're going to get rid of here. So, it all depends on the other thing, the single cos x. So, that's going to go. So, because the other thing has cos x in it, we need the replacement with just cosine x is involved. You might have squares, you might have twos, you might have ones and minuses, whatever, doesn't matter. So that's what we're going to do here. We're going to use that replacement, okay? Because we need to have cosines involved, or cos. What I mean by cosines here is cosines single x's. That's what we need, okay? So we need that there. Forget the squared because that's a cosine of single x. That is what we are looking for because we're looking for common factors. Okay? Right. So I've just replaced that there. Right. Okay, I've got that there. Right. How can I deal with that? Oh, what's happened there? Where are the two numbers upstairs gone? Well, don't know if you noticed it. See that -1 and +1. If you take -1, +1, they cancel each other out. So that's what's happened there. Right, pay attention. So I get 2 cos squared x plus cos x equals 0. I think I'm going to tidy this up a wee bit. The definition of cos squared x there is actually cosine times itself. So that's why I've written it out like that there. Right? Right, so it looks like I can see a common factor here. When I'm talking about a common factor here, that's one term and that's another term. What do they both share? Well, I'm going to put a 1 in front there. Actually, let me see here what I've done there. I'm going to put in another wee line here. Sorry, I don't like to edit on the go here, but I'm going to, because it's beneficial to you. Use a bigger rubber. Right. So that, right, see if you just got single cos x, that's why I put the 1 in the front, because see when I factorise, I want to have something left. Right, so I'm going to factor out cos x from both. So cos x is going to come out. I've got one there and one there, and what am I left with? In the bracket, I'm going to have 2 cos x plus 1. So that's why you're going to be seeing that in the bracket. So the cos x in yellow, or whatever colour that is to you, that's going to go at the front. And I'm going to be left with cos x plus 1. Right, so that's how I got that there. Okay, so okay, something times the stuff in the bracket equals 0. The only way that's possible if the stuff at the front is equal to 0 or the stuff in the bracket is equal to 0. That's what I've done there. Okay, I'm running out of space here. Probably take this on to another page. Done that. Oh, but before I did that, can you just see on the right hand side, 2 cos x plus 1 equals 0. So that'd be 2 cos x equals negative 1. So cos x equals negative 1 over 2. Cos x equals negative half. I've done that there. Remember, we're in the big class here. We should be able to do that. Right. Okay. So there's the one on the left. I'm solving for that. Cos x equals 0. Solve for that. When it's equal to 0, 1 or negative 1, use the graph. That's what we're doing there. Cos x equal to 0. Where is it crossing? Where is it crossing the x-axis? So that's what x is. That's what you're solving for. Where does that curve meet the x-axis? At 19,270. Right. That's your answers. 19,270. Let's get the other one. Cos x equals negative half. I think we need a quadrant check here. Where is cosine negative? Cosine negative. Well, it'd be positive now on cosine, so it must be negative in sine and tan. Right, done. Okay, there's your wee formulas. Bring A on board. Oh, and do you notice? Please notice I've got rid of the negative at this part here because the quadrant check, that's taking care of what your solutions are going to be. A, the calculator answer is always positive. Right, it's always positive. Unless we say otherwise. So calculator answer 60. Why don't you go and pop that 60 there, your calculator answer? Why don't you pop that into the highlighted solutions of 180 minus and 180 plus and see what you get. I'm sure you're good at counting. Did you get 120 and 240? What was your other two answers for the graph? What was that? 90 and 270, I think. Yeah, it was. Okay, why don't we group them together? Put them in numerical ascending, descending order, or jumbled up. It doesn't matter as long as you have those four solutions here. If you get any doublers, you would only write them once, but we don't have any doublers. Okay, so that looks like that's my answers here. I'm fine with that. That's good. Right. Okay. I'm up to 9 minutes and 40 there. It's fine. I don't want this to go on too long. So, sin x take away cos 2x. You know we're going to get rid of that. You know it depends on that. Right. Okay. The replacement it's got to be 1 minus 2 sine squared x, because the other thing was sine x. I'll put that in. Right, so what I'm going to see, that negative, that's really a negative 1 in front of the bracket. I'm going to multiply out the bracket by negative 1. What do I get? I get that there. And what's this? Can I tidy up here? Well, I'll get a negative 1. I'll get a positive 1. They're equal and opposite. They'll cancel. So I'll just end up with sine x plus 2 sine squared x. Okay? Right. How can we deal with this? Well, like we did earlier, sine squared, something squared is something times itself. So that's why I've written it like that there. Okay? Right, so that means I can identify the common factor. It looks like it's sine x, or sine x is everywhere there. So take out the sine x, and what I'm left with, I could have put in a 1, but I didn't. But I'm just going to show you. If it's single sine x, that's why when I took out a sine x from there and a sine x from there, that's why I was left with, in the bracket, 1 and 2 sine x. So that's why I've got that there in the bracket. It's good to show you. And the common factor was sine x. So that was that part there. Remember, I keep saying that you can always rewind these videos just to see what's going on there. Where did that number suddenly appear from? He's not explaining this correctly to us. I am a he, by the way. Right. So that's how we get to there. Right. So you get something times something equals 0. So that times that is equal to 0. The only way that's possible mathematically is if they're separately equal to 0. Sine x is equal to 0, or 1 plus 2 sine x is equal to 0. So that's what's going to happen next. Separate, we're going to separate and solve. SAS, separate and solve. Sine x equals 0, that suggests a graph here. 1 plus 2 sine x equals 0, that suggests messing about with it to get sine x on its own. So I've done that there. We should be able to do that. Right. Sine x equals 0. Let's use the graph. Okay. We know we're not including 360. So that's my two solutions. X is 0 and x is 180. Other one, sine x equals negative half. Oh, where's sine negative? Well, it'd be positive in all in sine, so it's going to be negative in tan and cosine. Right, there's my wee formulas here. Remember to replace x with a and get rid of the negative. Do you have sine a equals positive half, sine a equals a half? Then do inverse sine a half, sine with a wee minus 1/2. What do you get in your calculator? Shift sine a half, do you get 30? That's what I get. Okay, so fire them into 180 plus 30, 360 minus 30. Do you get 210 and 330? That's what I get. What was your other answers for the previous part? 0 and 180. Yep, let's group them together in order if you want. Whatever. That is my answers. Okay. I think I'm fine with that. That looks good. And do you know what? That looks like I've kind of completed the basic double angle formula solutions. But there will be a twist in this later on. So if you think I've went through this a wee bit quicker, then you're quite right. It's because initially we take our time. You need to take ideas on board. That's your job. And I keep on saying, you can rewind these little videos and get a translator to work out what language I'm speaking and what accent I've got. Right, on my knees, on my knees. Right, okay, folks, I'll see you for now. Right, bye, enjoy.